the amazing green tech stage, biotech, nanotech, everything, all the technologies that will save our planet. And here we have another speaker on the green tech topic, all the way from München, Christian Meknes. Like a warm applause for Christian Meknes. He will hold a brief talk about. He will have a brief talk about smart grids, smart offices, and smart homes. Thank you, Christian.
Thank you. Welcome from my side. Thanks for being here this morning. My name is Christian. I'm from Munich. I'm actually from university, and the presentation before was a pretty good segue for what I'm going to talk about today. The Changes is a really amazing product, I think, and I'm going to talk about prototypes and visions we have. So we were working on different projects in a bigger scale. So we are actually talking about smart grid and smart homes. So basically the Changes model in visions and prototypes, hardware and software prototypes that we developed over the last couple of years in a bigger scale. So for the whole building or for a whole smart grid. And I want to show you different visions we have for the future, so what kind of products we will see. Please take these visions and develop some companies out of them. Take some of our ideas from our prototypes we developed, so we have hardware and software prototypes. Take those ideas and develop some cool companies with these ideas. My background is from university, so I'm from the Technical University of Munich, and I come from the CDTM, which stands for Center for Digital Technology and Management. So we basically look at the technologies, digital technologies, and a little bit the market around and how to actually develop some visions and how to develop some ideas into future enterprises, startups, and companies. And we want to bring out our visions to the public, so the people that are interested in these topics take them, develop some companies, create some startups with these ideas, and maybe collaborate with us. But our idea is basically to inspire people around certain topics. The topic I'm going to talk today is, of course, green tech, is renewable energies, smart grid, smart home, and smart offices. But first I want to introduce a little bit the CDTM and why we think we know something about these topics and how we actually do our work. So the CDTM is basically a center that is built or managed by both universities in Munich. And we have each semester about 25 students out of 200 applicants that do work on projects. And some of these projects were renewable energy, smart grid, smart home. And all these projects are real world projects. So we always take problems from the real world, from the industry. We work with industry partners. And we put these student teams on these projects. And we had 3 years of projects in the area of smart grid and smart home. We always work close with industry, with startups. And we also want to, of course, generate startups out of these ideas. So whoever is interested in building a company in these areas, please approach us, please come to us. We're always happy to discuss ideas with you and maybe help you get started in this area with a business idea. We do research in a couple of fields, not only renewable energy and smart grid. As you can see, we also work in e-health and electronic or computer technologies and how to support elderly or sick people. We also look at German software companies and how to excel these software companies. We look at telecommunications, and we are part of the European Institute of Technology. But the important topic today is renewable energies and smart grid, which we have been working on for about 3 to 4 years. As you can see below, we have a success record of about 60 companies that were founded out of our research projects, our ideas, our visions we created. So 60 successful companies that are still up and running came out of these projects, and we hope that out of these smart energy and smart grid projects and ideas, another 60 or even more companies will come. So whoever is interested in picking up the ideas, please go ahead. I want to give the word to our students and some of our, or one of our professor that actually is able to introduce the CDTM even better than I am. So a short video to get you started and to relax a bit. I hope we have audio. I think we need a little bit
more. It takes additional ingredients. A place to meet the right people and to learn the necessary skills. That's exactly what the CDTM offers.
The Center for Digital Technology and Management is a joint institution of both Munich universities, the LMU and the TUM.
For me, the CTM is like a great adventure. You get the chance to meet new people, to learn a lot, to go abroad to the US. So it's more than just a study program.
We aim at teaching our students the skills relevant for any career at the interface of business and technology.
We focus more on application rather than on theory.
We actually build things, and that involves designing, programming, soldering. We're not trying to make techies into business students or business students into techies. What we want to do is teach just the right amount of knowledge so you can truly understand each other's perspective.
The topics of the CDTM courses are very diverse.
I always had those cool ideas about new products, but never the knowledge and the skills to bring them to the market. Here at the CDTM I learned a lot about product development, marketing and financing to be able to realize those ideas.
If you're looking for a partner to do your startup, then you should definitely come to the CDTM.
And when you hear about the success stories of your fellow CDTM students and of CDTM alumni, it's really highly motivating and it keeps pushing me to my limits.
You put a lot of work into it, but you get so much more out of it.
The CDTM is a home for your ideas.
So this is just to get a little bit started. So the home for our ideas, and the ideas we talk about today is of course smart grid and smart energy. Why do we think we have some knowledge or some ideas in this area? So we've been part of the e-energy projects of the German government basically for 3 years, and we published reports, future scenarios, and we developed prototypes. So prototypes involved hardware prototypes, as you have seen before, and also software prototypes. And I'm going to show you a couple of these ideas, these visions, and some of the prototypes. Unfortunately, I couldn't bring them with me because they are all installed in some lab environment where maybe a building or an office building or a home is simulated. So if you actually want to try out these prototypes, come to Munich. You can try out these in a real lab setting where they are installed and where you can actually try and play around with these ideas and prototypes. But I will show you pictures, I will show you screenshots, and I have a couple more videos where you can actually see people interacting with these prototypes and how they actually work. So, but first I want to introduce you a little bit to the problems we have with renewable energies. So that the challenge we are facing and the challenges that the visions and the prototypes are actually trying to solve. One of the challenges is, of course, we want to get rid of this. So the idea of renewable energy is to get rid of nuclear energy, of coal, the pollution of the air and everything. So we want to rely on photovoltaics, on wind energy and other renewable sources of energy. But there is one huge challenge. I don't know if you can see the picture. I was hoping for a bigger screen. But on the right you can see at the bottom, which is called base load, all these dirty energy sources are. So the nuclear power, the brown coal, they provide our base load for basically the whole developed nations. And the base load means from midnight all day long, a steady output of energy. A steady output of energy is required so that our systems, our industries, our factories, our public transportation, so that everything works. And the question is, can renewable energy sources really substitute or be such a base load and yeah, basically substitute nuclear energy and coal? And this is one of the big problems because renewable energies, as I guess most of you know, are very volatile. So the volatility, they don't produce energy in a steady base load fashion. So they produce, like for example, here you see the output of a photovoltaic. At midnight or when there is no sun, of course, there's no energy output. Around noon, when the sun's high, when the sun's strong, the photovoltaic, the energy production is high, sometimes even higher than the consumption. And this also reflects on the price. So in a model like this, the base load would not be possible to actually be generated by a photovoltaic. The price would be too high. So our energy price, the energy price would be much higher than we actually wanted to have. So there needs to be systems, there needs to be visions and ideas how to get rid of such a volatile, an alternating generation of energy with renewable energies. And there are some ideas, and one of the central ideas I'm gonna show you. This is basically the concept of a microgrid. Microgrid is basically the central idea on how to develop a system, a technology that is somehow smart, and also is able to basically flatten out such a volatile generation of energy. And I show you a little animation our students built, where you can actually see how such a microgrid is smart to develop some energy and to flatten out the curve. At first, you can see the status quo. So there is no production on the top left. There is no production at night. When the sun comes up, the production of energy starts. So the photovoltaics on the roof are actually generating energy. And this person, for example, is selling all its energy to the energy market, to the provider he has. So he's making money. He's making money with the photovoltaics he has on the roof. But the problem is still around noon the production is very high. So he's still producing a lot of energy, even more energy than is probably needed. And when the sun goes down, of course, the energy production stops. So the most straightforward solution for such a problem to straighten out this very, very peak production of energy is to build some clever system into this house. And such a clever system is basically such a smart microgrid system. As you can see here, it basically is a microgrid system that is somehow clever. It is a battery, and there is some control mechanism in the middle. So when there is energy production, when there's a lot of energy production, energy is stored in the battery, probably in the basement of your house or even in a huge battery park in the neighborhood. So energy is stored for later. Of course, also the plugs in your house are supported, and if there's more energy than you need, you can still sell some energy. When the sun goes down later on, of course, energy production goes down, and at some point, some energy needs to be taken out of the battery. So this system needs to automatically and intelligently control the energy flow in your house and in this smart grid. And at some point, some energy comes out of the battery, still supports your house, so your appliances, your computer and everything works. Maybe you can even sell some energy, so some energy flow still goes out of your house into the grid, so you can actually earn money still with your photovoltaics. And of course, when there is no energy production from the sun, the battery powers the energy sources of your house, and the battery powers also maybe some other parts of the grid. And as you can see now, you basically have a flattened output of energy, which would allow for a substitution of the base load of the nuclear and the coal power, which is, of course, what we want. A smart grid typically is not only one house, but a couple of houses, a whole neighborhood. And then it gets really interesting, because of course not every house needs to have a battery. You could have one battery park in a neighborhood, and all the houses basically build such a smart grid that tries to generate such a base load output of energy to substitute nuclear energy and to substitute coal. So the thing I want you to remember is basically the idea is to have a battery in a smart system and basically even out the volatility of these energy production sources. So this was about the introduction of smart grids and what we've been working on. So this is basically the foundation of all the projects and all the visions I'm going to show you now. So the CDTM has, or I could say there's an evolution of basically visions we had and then some prototypes that came out of these visions. So students then developed software and hardware prototypes to basically put some of these ideas, some of these visions into real prototypes people can work with and people can experiment with. So what do we have? We have 3 visions I want to show you, which are called E-Energy OS. So this is basically a software vision for how to control such a smart grid. The storage cloud, you can already imagine maybe that it has to do with battery storage in somehow a distributed fashion. And energy on the go is basically some idea on how to take your energy from your home with you when you're on a business trip, when you're moving maybe to another apartment and stuff like that. And then we developed some hardware and software prototypes out of that. The first one is a smart plug that you can actually plug between your devices or your household appliances, and that is able to measure how much energy you produce, and that is also able to give you recommendations. The next one is a smart home appliance called Neo that allows you to control your home and also incentivizes you to save energy. And the next one is a smart office. The Griddle is a smart office appliance or a smart office prototype. The most recent one that helps a whole office building or a whole company to motivate the people to save energy through basically gamification concepts. So the idea is to motivate and incentivize the people, the employees of a company, by letting departments or individuals compete around saving energy in the office building, and basically optimizing the whole grid in a whole office building. So let's jump into. The first one is the visions of the future. So this could be, I don't know, maybe your home in the future, or maybe even an office building in the future. You have a huge tablet on the wall that basically introduces all the news you want to read, that allows you to play videos and audio, but that also visualizes your current energy production. So as you have seen before, your house is generating energy, but it's also storing energy in your battery or something. And such a system could actually give you all the information, how much energy you're producing, how much costs you have already due to your energy consumption, and how much money you earned by selling your energy to the energy grid or somebody. And at the bottom you might also see how much the energy currently costs, and you can decide if you wanna actually turn on the TV now, or if you wanna do a washing cycle or something. So such a system, we envisioned as, we called it, or our students called it, the Energy OS. It's basically a cloud computing system, or would be a cloud computing system where third-party developers can add some new applications, some new functionalities. And the main idea is basically energy management around the whole thing. So energy management is the central point. In the middle of the screenshot, you see all your different devices, like the TV, your washing machine, your fridge, and you even see how much energy they are how much energy they are consuming, and how much energy you could save if you optimize the whole cycle, if you optimize the smart grid. So it gives you recommendations how to better save energy, how to better optimize your smart grid system. And it gives you shopping recommendations, so if you want to buy some products that actually save more energy than the ones you have. But the really important thing is that it's actually an energy management system. So it has a two-way communication. First, it basically acts as an energy broker, so it sells your energy to the energy grid, but it also buys energy if it needs some energy. On the other side, it interconnects all your devices. And this is the most important thing. So all the devices in your house need to be somehow interconnected, so the energy management system is able to measure how much energy is needed, and so it's able to optimize the smart grid system that you've seen before. And there are shopping recommendations I already mentioned. So this is one of the visions we have, and this is also one of the visions that was implemented as a prototype later. I will show you the screenshots of the prototype later. The storage cloud idea is, as you can see already in the picture, around batteries. So this is a battery park. This could be in a future neighborhood or something, a huge battery park where the excess energy, the energy that was produced and not used, is actually stored for the night. This is an energy park prototype that is actually deployed right now in Germany, and some wind energy and some solar energy is already stored in these batteries and then used at night to be distributed to homes or to office buildings. And such a storage cloud could of course be using the energy park, such a battery park, but also data centers, airports and banks. So they will all have batteries in the future. And the storage cloud basically connects all these battery parks and battery resources into one single unit. Like you know from cloud computing, you have one single unit where you can put your energy to, The energy is stored in this single unit, and whenever you need some energy, you can get cheaply energy out of that. So as you can see, there is a customer that actually puts some energy into this cloud, and whenever the customer needs energy back, he just takes it back from the cloud. You can also do trading with this energy. So trading, there's energy markets like the stock markets with companies. There's energy markets where you can actually buy and sell energy, speculate on energy prices, and you might even make a profit if you put some energy in such a storage cloud, sell it on a higher price on the energy market. So there's all kinds of applications that are possible in the future with such a storage system, such a decentralized storage cloud system. And that the other idea is energy on the go, what we call it. It's basically around 3 use cases. I don't know if it's a little bit small, I guess. So the one on the left is about being on the move, being maybe in an office space, maybe being in an airport or somewhere, or at a lounge or a bar or something. The idea is basically you go there and you have some kind of a system that allows you to charge all your system, that allows you to actually get energy wherever you are. The other use case on the right top is basically if you move into a hotel or something, or if you change your apartment, the energy you have, the energy contract you have moves with you. On the bottom you have, of course, an idea about a smart system about electrical vehicles. So also, of course, in the future, the whole energy system needs to somehow deal with electrical vehicles. And the idea is basically you can plug in your electric vehicle wherever you are. You can even offer maybe a charging station at your home or in an office building. And of course, public parking might offer plugs for you to charge your electric vehicle. And the overall idea is very simple on the top. So you have a user authentication, maybe with a fingerprint or something. You unlock the energy wherever you are. So the idea is that you actually have an energy system that is interconnected worldwide, and wherever you need energy, you just unlock it with a user authentication, and you charge your devices, you charge your car, you charge your computer, whatever you are. There is real-time billing behind it, and you actually you pay as you go on a global scale. So as you can see at the bottom, the energy on the go system combines or links the customer with the smart plugs, where you can plug in your devices. Of course, the energy comes from the right, from the energy utility, but the idea is actually to build a worldwide system that actually allows you to charge your devices wherever you are with one single bill on such a device. So this is basically the visions, and some of these visions were actually implemented in prototypes. As you can see here already, a very popular platform is the Arduino platform for developing hardware prototypes around these devices and visions. And the first hardware prototype that we developed, I want to show you, is Alva. So this is about smart home. So it's not smart office. We are looking at smart home and actually how to interconnect the different devices in your home, and how to also save energy at the same time. And the first thing you need in such a system is basically a very simple device that provides these 3 functionalities. So first you need to somehow meter how much power you're consuming. This is a little bit like the changes system did. So you need some device that actually measures what your devices, what your computers, and what all the devices in your home actually, how much power they are consuming. Then of course you need to control them a little bit, so you need to be able to switch devices on and off is the easiest way. The next step would be maybe an air conditioning, powering down the air conditioning or powering down a fridge and powering up. But now we actually implemented just switching on and off devices as the first step. And you need some communication between all these devices. Do we have a... So we're back, okay. The next step is communication. Since you have a lot of devices like light bulbs, you have the TV, you have all the devices in your home, you want to connect them, so you need some kind of a wireless connection to connect all these devices. And we developed the first prototype. The first step in this prototyping process was basically a very simple switch that actually allowed all these things. Based on monitoring, switching, and communication, you can do a lot of stuff. Of course, you can visualize the consumption of your energy devices very, very nicely in a graph, so you can present the user an overview. You can remote control the devices. And the checkout function is basically you turn off all the devices that you don't need when you leave the house at one point. But the most important thing is in the middle on the right is basically saving energy. This is the most important thing. Once you have a visualization and once you have the ability to actually control pieces of your home, you're able to actually save energy, and you have a transparent overview about your energy consumption and how much energy you're using and how you can save that. This is how it looks like, or this is how we envision that it looks like on the left. So it's basically a plug that you plug in between your devices and the power outlets in your home. And by doing that, you have a wireless communication about the consumption of the devices that are plugged in. On the right, you see a little bit of a diagram how it could look like. So you have maybe an oven, a TV, and a hairdryer connected to this plug. And the plug communicates with the central system, basically manages your consumption, visualizes your consumption, and also switches devices on and off to optimize your energy consumption. So this is the most basic thing you could imagine on how to build a smart home system that also allows you to save energy and to have a smart system in place. This is how the development looked like. So on the left you see one of our electrical engineers actually soldering and building this whole device from scratch in our lab. On the right, the screenshot is a little bit small, sorry for that, but you can see that there is already a consumption curve. So the device basically reports some information to the central system, and you see how much energy your device is consuming. And if you know how much the price for this energy is, you might maybe change your behavior in the future. On the bottom you have this red button. This red button is what we call the checkout button. So if you leave the home, all devices that are connected to this button are actually turned off. People know that from a hotel maybe. If you leave the hotel room, basically the hotel room is out of energy as soon as you take the hotel key. This is the idea for your home. If you have the checkout button, does the microphone still work? Yeah, okay. So if you have the checkout button, you basically turn off the devices you don't need, like your TV or stuff. This would actually save a lot of energy because most TVs are on standby, as you know, or a lot of devices are on standby, and just having such a button if you leave the home would make it very easy. This is what it actually looks like right now. So from this prototyping device, we went a little bit further. And you can see, number 1 basically allows you to plug it into a power plug. Number 7 then to connect your device to it. Number 2 is basically a relay that just turns on and off the energy flow. And the really interesting part is number 4, which is the Arduino with a wireless LAN shield on top that actually allows the communication of the energy data to the central system, and that allows also to control the whole plug and to control the whole system. And if you have like 15, 20 or 100 of these plugs in your home, you have a pretty complex system that you can actually manage your energy from and that you can control your energy system from. So this is the first easiest and smallest step in our energy production or in our energy systems. The next step is just building some software intelligence on top of it. So the plug itself is not very clever. The plug itself is only hardware that allows you to switch devices on and off and control something. And NRC is the intelligence on top, basically. So you have an energy report that transparently shows you how much consumption of energy you have. You can set your own goals, which is really important. So how much energy you want to save next month. And based on these goals, your energy tree on the bottom basically grows. So you have a visual representation on how much energy you're saving, and if you're doing really well throughout the month, the tree actually grows, and if you're doing really bad, the tree at some point maybe dies. So this maybe motivates some of the customers at the end to actually set a goal that is hard to tackle, but then actually to meet the goal and saving energy through the system. On the bottom left, of course, it gives you advice, because you need to know how to save energy at some point, and such an advice is really important to actually meet the goal you wanna achieve. So, I mean, the overall concept is very, very easy to understand. Of course, you have some devices that consume energy on the left. you have these smart plugs. So the plugs that we developed are part of this whole ecosystem. And then you have the platform on the right that actually gives you advice and allows you to meet your energy goals and allows you to store the data the plugs are transferring to the system. And this should allow you in your home to store or to save energy and should give you advice how to save energy. One very important thing is if you plug several devices into one of these smart plugs we have, the total consumption curve looks like the one on the left. So you have no idea what device consumed what energy. And the energy system, the NSC system, the intelligence system now is able to actually distinguish different devices that are plugged into one of these plugs. This is very important because a device can only be usable if you have really granular information about what device consumes what kind of energy. And if you have one of these smart plugs in your TV and your computer and your oven and several devices are connected to it, the NSC system algorithm that our students developed is actually able to take this total consumption and recognize what devices are consuming what kind of energy. And this is very important for all future recommendations and for the analysis of how to save energy. This is how it looks like. Pretty similar to what we've seen in the vision, the energy OS. So the ENA tree is here still very small, so it's probably at the beginning of some month or some cycle. At the bottom right, you see that in some months there is a red button where the energy goal was not met, and there are some green buttons where the person actually saved energy and was able to meet the goal he or she set himself. And on the left, you see the devices that are connected to the system. So right now, the fridge and the washing machine are turned on, and the other two devices, the oven, and they're all turned off. And it gives you advice. So it gives you advice when to probably start your washing cycle and when to start maybe cooking your dinner if this is applicable. But these are just some ideas. So this is basically the one simple prototype that was developed about 2 or 3 years ago. Based on this simple prototype, the next system was introduced, which we call NEO. It's an even advanced home automation system that basically builds on everything we learned from the system before, or from the NSC and the Alva system. You have one central base station in the middle. This is basically a base station that supports current standards. Home automation is a very big field, and there are different wireless communication standards around. And based on these standards, we wanted to extend our ideas and our prototypes to actually support these standards. So it is able to actually communicate with different sensors, as you can see in the top right, so motion detectors, power meters and stuff, and also actuators like our plug, some lights that you can switch on and off and other stuff. You have a smartphone system that allows you to control the whole thing. And you have an open system that allows you to actually develop apps for it. So the apps can actually tackle or access the information of the whole system and can then bring more value to the whole system. This is the whole idea of actually having the ability to put apps on such a smart home automation system. So what are the most important things that are part of the system? So first of all, the devices. We need to basically communicate with all the devices in the homes, and there is different manufacturers producing devices based on different standards, and we worked hard to actually support these standards and communicate with all the different devices in the home. Voice control was something that our students really wanted to have, so you are able to control most of the home automation system just by voice control, by talking to NEO. The links are important. The links are actually the connection points to these different devices, like the plugs, like different home automation plugs that you put in the walls or that you distribute throughout your house. And extend, I already talked about extending it through apps. So a third-party development system that allows third-party developers to basically access the data about the home and give even more value to the system that you have. I do have a little video about this home automation system I want to show you, just to relax a bit. Our students developed an overview how they imagine this system could look like.
The wings of the bluebird as she sings. The 6 o'clock alarm would never ring, but it rings and I rise, wipe the sleep out of my eyes. My shaven razor's cold and it's
Now he turns on his coffee machine from the back.
Cheer up, sleepy Jean. Oh, what can it mean to a daydream believer and a homecoming queen? Cheer up, sleepy Jean. Oh, what can it mean to a daydream believer?
Recognizes somebody walking into a room and basically turns on the lights. And this is how it looks like.
Sleepy Jean, oh, what can it mean to a daydream believer and a homecoming queen?
New? Goodbye.
This is the voice control where it actually turns off all the devices you don't want to have on when you leave.
Oh, what can it mean to a daydream believer and a homecoming queen?
As you can see, we work together with industry in this project also.
Sleepy Jean, oh, what can it mean to a daydream believer and a homecoming queen?
So, and this is what it actually looks like. You have already seen it in the video. If you open it up, it's also a hardware prototype, of course. The core of the whole Neo system is an Android smartphone that is basically built into the back, that is actually used for all the computation for the software that is developed. Then we have a radio module that is actually able to communicate with all the devices. So as I mentioned before, there is different hardware manufacturers that use different standards, and these radio modules are able to communicate with all these different standards like ZigBee and so on, to actually control all different devices from different manufacturers in a house. You have an I/O board that actually connects to the Android, and of course a microphone for the voice control. So this is the most basic, the basic system that was developed as a hardware prototype that actually runs in one of the lab settings in Munich. On the right, you see the front cover. The front cover actually now shows an iPhone in the back. So the iPhone app that was developed is the one that the user actually uses. So you could also imagine taking this iPhone out and running around in your home. Then you have a mobile system that allows you to control your home. Right now this iPhone is built into the front cover. If you put it onto the Neo, then you have basically a system in your home somewhere centrally where you control the system. But of course the iPhone would also work in the whole building or even outside the building. This is how the iPhone app looks like at the moment. You've seen in the middle this coffee switch. So that actually there's a link to the coffee machine, to the plug, that allows you to heat up the coffee. You can see, of course, a floor dimmer, so you can actually dim the lights in some of the rooms. The ceiling dimmers, you can change a window. So there's an electrochromotics window that allows you to change the density of the window. And you can even turn on water. So there is a manufacturer that allows you to communicate with a water tap through some wireless technology, and we also use that since it's a standard. We are compatible, or the Neo system is compatible with that, and you can turn the water on and off. So these are some of the prototype features that I implemented. On the right, you can see some of the sensors. So motion detection is if you walk into a room, of course. The window sensor measures if a window is open or closed, and there is a smoke detector and some of the switches in your building that actually communicate with the NEO system. So, but by using NEO, you're pretty much able to control your whole house already. And of course, it is linked with some energy management system in the back, so it actually optimizes also your energy consumption. But this is very much tailored for convenience and for having a good system to basically control a smart home and to control your home. So, and from the home environment, we now come to my last prototype that I want to show you, which is Griddle, which is in the office environment. So from the home environment, we went one step further and looked at if such an office building is a whole smart grid, how could a system look like that actually manages such a smart grid of such an office building? And our idea was Griddle. So the big challenge here is to actually motivate office employees to save energy somehow, or to think about saving energy in such an office environment. And the Griddle concept and the Griddle prototype tries to incentivize them by basically having a gamification concept. So having different departments or different people play against each other about saving energy, about looking after the smart grid that the office building is, and so the one thing, of course, if such an office building is a smart grid, as you've seen before, the whole system needs to adjust the energy production. So you might have photovoltaics on the roof. Maybe there is even some wind energy somewhere in the office park or connected to the office building. And of course, you might have some storage capability. So you might have some batteries in the basement. And then the whole office building is basically a very intelligent and large smart grid system that could be self-sustainable, that produces energy at some point, and that also needs to be managed, of course. I mentioned before, to motivate the users, our students went out and asked a lot of people, a lot of office employees, what would motivate them most to think about the energy production, to think about the office building, and basically the involvement and the gamification concept was the concept that came out that would actually motivate the users to participate in such a system. And this is what Griddle does. So it actually has some gaming concepts to enable an optimal operation of the microgrid. But this is, of course, what the idea is about. The users are motivated because they have fun and they want to participate in such a system. So this is how it looks like. It's also a two-piece application. So it's a smartphone app, and it's an ambient screen that the office building puts up in certain places in the office. So the smartphone application informs you about your office, informs you about the current leaderboard. So there is, of course, the gamification concept very, very central in the application. So you see what department is leading or what person is leading at the moment with saving energy. You have a remote control facility, so you can remote control your office or even some seminar rooms. And you see your consumption, so how much your office is actually consuming. So this is basically what every person would have in his pocket. And there is some screens that the office management system would be all spread out over the office building, that allows the whole department to see what's happening at the moment, to see also how the departments are doing, to see how much energy is currently being produced and how much energy is used, and inform basically the office employees about the whole system. So, and this is how it looks like if people are actually using it in a real environment. This is the screen that would be somewhere in the office building. The user can control his own office. So you've seen this device or these two devices in the video. So on the left, the ambient screen that gives an overview about the whole microgrid, and on the right, you have the personal device that you can use. This is where the system is currently running. So it's at Fortis. Fortis is basically an institute of the Technical University of Munich, and they have something they call a living lab. So they have a whole office building that is basically a microgrid. They have some photovoltaics on the roof. They have a battery system, an e-car battery system in the basement. They have power monitoring systems, and of course they have now also the Griddle system. And based on this, and they have a climate control that is also tapped into this whole system. They work together with Siemens, and we work together with them to basically deploy this system there in Munich to have people try it out. So if you ever want to see it live, talk to us or talk to the Fortis people, and you can actually go into this living lab and experience how the Griddle system would actually work. So that's it from my side. These are my contact details. So if you want to try out any of these prototypes, if you're ever in Munich and want to see some of these prototypes, just contact me or just go to cdtm.de. Thanks. And of course, there's maybe a question or two. We have 1 more minute, I guess.
Test. Test. Have you already implemented the Griddle? Have you already implemented the Griddle in an office building? And do you have any numbers if it's really helped with the energy consumption?
Right. So this living lab, they are running Griddle at the moment. So they are actually using it with all these different devices from Siemens. The first test was only a couple of weeks, and now they are running a long-term test on how such a Griddle system would actually save energy. The first couple of weeks test actually showed that there might be savings up to 15 to 20%, but now on a long-term basis, if people at some point are maybe fed up with actually using the system every day, of course such a long-term study will show how well such a system runs. And I think now the Living Lab is trying to have a 3 or 4 month long-term study on how such a system could actually be implemented and working. Yeah.
You talk basically about communication, wireless communication between devices. Why not power over? Why not communication over electrical line?
This is also a good way. I mean, the problem is many of these devices, of these smart home appliances, they don't need any cables. So you might be able to put a plug or a switch just somewhere on the wall, and there is no cable attached to it. And this is actually, I think, or we think, the future, that you don't need to put any wires or cables into the building anymore. And that's why we actually went with wireless technology. Of course, it will also be possible to put this on a wire, but many of the devices that we work with that come from manufacturers, and many of the standards are already wireless. I think the industry tries to actually get rid of wires and make most of the stuff wireless to not need to open up the walls and stuff, and to actually be able to put everything in, even though the building is built already. Yeah.
Hello. About the houses, and how much would it cost for a consumer to put this system into his home? Were there any estimates made about this?
This is a difficult question. Yeah, I mean, right now I think E.ON, one of our partners, has a system that they price with a couple of €1,000 for basically a one family home. Yeah, but I'm not sure how many different devices this system would actually be able to communicate with. But I think I mean, the hardware and everything we produced was really cheap. So the system itself, the development itself, can be done really cheap. The real products, I think E.ON is one of the biggest right now, and Siemens also offers some system. You should look up the prices online. We didn't look at the prices, but I think a couple of thousand E.ON asks for its first product they launched a couple of months ago. Great, thanks.